Hello there, Charger family. This is Mrs. Boyd, Mrs. Boyd's Math Room. Thanks for joining me today for a rousing discussion about one-step inequalities. Now that we know so much about solving equations, we're going to put all that knowledge into solving inequalities. Let's get started. When your point of your inequality sign is heading towards the left, it is less than or is fewer than. If you can imagine we're reading from left to right, we could say x is less than 0 or something like that. So the less than comes from we're reading in the left to right direction. We don't really need these letters, so let's get rid of those. So we need to write an inequality, which is a lot like writing an equation, and we know how to do that. All right, so we've got the sum of x and 3, which is x plus 3, is less than 8. Well, we're going to solve this exactly like we would solve a one-step equation. We're just going to pretend for now that our inequality sign is just like an equals. So to get x alone, which is our goal, we need to subtract 3. The opposite of plus 3 is minus 3. So x comes down, plus 3 minus 3 is canceled, is less than 8 minus 3 is 5. So that's our solution. X is less than 5. We're going to talk about a thing called set builder notation, and it's always going to start with these fancy brackets. Our variable that we're talking about is going to go in front, so we're talking about x. And then we get this vertical line, and this reads x given that. So the vertical line means given that. And then we put our solution. X is less than 5. We're going to always use these with inequalities. Always. So this will read x given that x is less than 5. We want to graph this. So we need to, let's label our number line. 1, 2, 3. Oh, 2, 3, 5 is definitely not right. Holy cow. 2, 3, 4, 5, 6, 7, 8. So our solution's at 5. And since it's x is 5, so the less than tells us it'll be an open circle at 5. That means that 5 is not a solution, but every point infinitely up to 5 is included. So we want to imagine, we want to look at our number line and plug in some points from either side of our circle to see which way our solution will go. So we look at 6, for instance. Is 6 less than 5? You have to ask yourself. No, 6 is greater than 5. So we know everything to the right of 5 is not a solution. So let's go to the other side. Is 4 less than 5? Yes, it is. So we know everything to the left of 5 is a solution. So to show that, we're going to have to make a line along the number line with an arrow on it that shows that all of the numbers to the left of our solution are also solutions to this inequality. Your line doesn't have to be nearly as thick as mine, but you have to be able to see it nonetheless. Let's look at greater than now. So if we look at greater than, it's open in the opposite direction. So it opens towards the right. And just like above, if we were to say x is greater than 0, just like we're reading from left to right. It also says is more than, is greater than, is more than, x is more than 0. Let's write an inequality. 5 subtracted from m, so m minus 5 is more than negative 11. Again, we're going to imagine this is just like an equation and solve accordingly. We want to get m alone, so we will add 5 to each side. And we have m, 5's cancel, is greater than negative 6. We need set builder notation, and I didn't leave myself any room, so I'm going to put it over here. Hopefully you left yourself some room. Fancy bracket. M, given that M is greater than -6 will be our set builder notation. Let's fill out our number line. -6 and up and down. So our solution is at -6. We know that it is, we need to plug in some points. So let's test -7. Is -7 greater than -6? No, it's not. -5 is, though. So our arrow is going to be pointing this way. I did forget to tell you my shortcut. If your variable is on the left of your inequality, your shaded arrow will point in the same direction as your inequality. So x is less than 5, the point is pointing towards the left, so your arrow will also point towards the left. M is greater than 6, the arrow point towards the right. That means our line is shaded towards the right. Okay, that again, that only works if your inequality is written such that your variable is on the left. Next, we've got is less than or equal to. So it looks like less than and has this extra bar on the bottom that is kind of like an equal sign. Other expressions that you can use to mean less than or equal to is at most and is no more than. Those are confusing ones. So it's good to remember what expression those go with. Let's write an inequality. The difference of b and 1/2, so b minus 1/2, is at most less than or equal to 3/4. Well, we're going to have to solve this a lot like a equation. So we need common denominators first and foremost. So we know that 1/2 is the same as 2/4. I'm just going to rewrite it that way. To get b alone, we need to add 2/4. My kitty is talking. And we're left with b is less than or equal to 5/4. Set builder notation, b, given that b is less than or equal to 5/4. Let's put this on a number line. Put 5/4 right in the middle. That's a 4. Holy cow. 8/4, or that could be 2. 4/4 or 1. So our solution is at 5/4, but this one's different because of the equals part. Anytime there's an equals involved in your inequality, that means you're going to have a dot instead of a circle. Less than 5/4, 6/4 is more than 5/4, so 4/4 is less than. So our arrow will point to the left. Also, our inequality sign points to the left, so the arrow will go to the left. Last but not least of these, let's look at greater than or equal to. It can also be used for is at least or is no more than. We've got 10 added by n is no greater than or equal to 12. So we want to get n alone. We subtract 10 from each side. And we've got, I don't need that 0 there. What in the heck am I doing? Okay, n is greater than or equal to 2. Set builder notation, n, given that n is greater than or equal to 2. We want to fill out our number line. Our solution is at 2, and there's an equals involved, so we get a dot. Greater than means we're going to point towards the right, just like the inequality shows us. Okay, now that we've kind of learned about how these work, let's solve some inequalities. Translate each sentence into an inequality, solve the inequality, and put it set builder notation and graph. We can do that. The sum of a number x, not a, read the whole thing, Ms. Boyd, x and 17 is no less than, that means it's greater than or equal to 26. Well, we need to subtract that 17 from each side. We've got x greater than or equal to 9. Set builder notation, x given that x is greater than or equal to 9. 9 is going to go in the middle. Circle on 9, and it's going to point to the right. Excuse me. So I think you should pause here and try the rest on your own, or you can follow along. Twice a number x minus 4 is less than 3 times the number x. Now we got to get the x's together, so we can subtract 2x from each side. Excuse me. We get negative 4 is less than x. Well, we want to flip this around the other direction. So to do that, I'm going to write the signs in their opposite spots. I notice the point is pointing towards negative 4, so I have to flip that around and make sure it keeps pointing towards negative 4. Now I can put this in set builder notation. X given that x is greater than negative 4. So we fill out our number line. Circle at negative 4, pointing towards the right. Let's keep on last two. 12 is at least greater than or equal to a number x decreased by 7. Well, to get x alone, we got to add that 7 to each side. And we've got 19 is greater than or equal to x. So we got to flip it around again. X and 19 trade spots. The point is pointing at x, so we have to keep it that way. Now I can put it in set builder notation. Fill out my number line. There's an equals portion of the inequality, so it's going to be a circle on 19. And the point is pointing towards the left, so our arrow points towards the left. Last but not least, 8 plus 4 times the number x is greater than 5 times the number x. We want to get the x's together, so we'll subtract 4x from each side. 8 is greater than x. We got to flip it around. X and 8 trade spots. The point is pointing towards x, so it has to stay that way. Oh, that's the ugliest bracket ever. I apologize. Holy cow. Fill out our number line. There's no equals in this one, so it's an empty circle, and it's going towards the left. I hope these make sense. I hope you reach out if you have any questions, and I really hope to see you soon.